dividing polynomials. Now we've done something similar. If we look way back in the very beginning, we divided polynomials by a monomial. So like dividing it by just one term. What we're going to do today is dividing it by a binomial. And I'm going to sometimes we divide and you can factor and it works out nice and neat. We're going to just skip over those. We're going to do the ones that require synthetic division because you can do this no matter what. So synthetic division is a way that we can divide when factoring isn't an option. And actually it's going to be the only way you know how to do it anyway. So when we divide polynomials, they're not always going to divide evenly and perfectly. Like if I said to do 48 divided by 5, would you get a whole number? No, you would not. You would get a decimal, and in elementary school, when you divided 48 divided by 5, if you had a number left over, what did you call that number?
Remainder.
The remainder. So you had a remainder. That's kind of what we're doing. Now, synthetic division, it's a process. You've got to memorize the steps, but once you memorize them, you can do them really quick. Okay. So if the remainder is 0, then you have found an x-intercept. Normally, we would do some more with this in another lesson, but we are skipping that right now, so you don't have to worry about that too much. So synthetic division, first of all, you have to set up the problem. Okay. So you got to fill in some numbers. I've drawn boxes on this first one to guide you. You won't always have those boxes. You'll just write in some numbers. So in the top left corner, you're going to have like a number, and that number is going to be the opposite of whatever you're dividing by. So we're dividing by x plus 8. It's basically like I'm setting that equal to 0. If I set that equal to 0, I would get x equals what? Negative 8. So that's the number that goes in the top left corner. And then you're going to fill in your coefficients to your first polynomial. So the numbers in the front. So technically what's in front of the x squared? 1, 3, and then a negative 43. And from here on out, it's bring down, multiply, add, multiply, add, multiply, add. So you bring down this first number where I drew an arrow. Bring down the 1. And then we multiply this number times our corner number, so our negative 8. So what's 1 times negative 8? Yep, and that goes here. So we multiplied, and then we add straight down. 3 plus negative 8 is what? Now we multiply. Negative 8 times negative 5 is 40. And then we add straight down, and we get what? Negative 3. These new numbers tell us like the coefficients of our answer. So here's what I want you to do. We're going to start on the far right and work our way over. The far right number, the negative 3, that is going to be our remainder. The next number in line, that is just going to be a plain number, which is we call a constant. The next number over is going to get an x with it. If I had more numbers, The next one would get x squared. The next one would get x cubed, and so on. But it's always remainder, number, or constant, x, x squared, x cubed, x to the fourth, as many as you've got. And so we can write our answer as 1x minus 5. And then our remainder always goes on top of what we were dividing by. So it's going to be minus 3 over x plus 8. So it is a lot, it is a process, but once you get that pattern kind of memorized, you can do them pretty quick. And I'm going to show you how you can do them in the calculator. X squared, or check it in your calculator, I guess. 3 divided by x plus 8. I get that. And then I'm going to check my answer. 1x minus 5 minus 3 over x plus 8. Do they match? Yep, they do. So I did it right. Now we're going to do some more examples. So I'm going to set up a problem by putting some number in the corner. What number am I going to put up there? Close. Positive 7. It's basically going to be the opposite of that number. So I'm dividing by x minus 7. You're going to put a positive 7 in the box. And then what numbers go across the top? 2, yep, 2, negative 16, and 19. Leave a space and draw a line. So what's my first step? Not yet? Bring down the first number. So I bring down the 2, and then I multiply. 2 times 7 is 14. And then you add. What do I get when I add? Negative 2. And then you multiply. And what do I get? Negative 14. And then I add to get what? 5. Okay. So you're not done here. This is not your final answer. Start on the far right. 5 is my what? Remainder. Negative 2 is going to be, it's just my plain number, which is, we call it constant. And then from there on, I build up my x's. So this one gets an x. If I had another one, it would be x squared, x cubed, and so on. And so my final answer is 2x minus 2, just a plain number. And then what do I do with my remainder? Yes. It goes 5 over x minus 7. And that's your answer.
So, Ms. Johnson, where would we put in a situation where we would then have to solve this equation?
No, probably not. All right, number 4. Set up your problem. What number goes in this top box? Yep, you always take the opposite of that. So basically, really what I'm doing is x minus 2 equals 0. If I add 2, I get x equals 2. So a 2 is what goes in the top left box. And then your coefficients, which are 1, 5, -7, and 2. Those numbers go across the top. So for you that just came in, this is a method of dividing called synthetic division. It's a way to divide when it doesn't divide evenly. There is another method. It's a long division. You'll learn that in Mr. Adams's class. But I just do synthetic division. So you always bring down your first number. So bring down the 1. And then you multiply. 2 times 1 is 2. Add. So it's multiply, add, keep going. So what's 5 plus 2? And that 7 goes down there. And then I multiply that by the 2 to get 14. And then I add straight down to get 7. And then I multiply by the 2 to get 14 once again. And then I add to get 16. Number, we go backwards. The last number, the 16, is your remainder, and you always put your remainder over in a fraction what you were dividing by. The next one is going to be your constant, so it's just a plain number. It does not get an x or anything. So I just like to put number into there. And then the next one gets an x. The next one gets an x squared. If I had another number, it would be an x cubed. And then x to the 4th, x to the 5th. So it's 1x squared. You don't have to put the 1. Plus 7x plus 7. Just a plain number. And then my remainder is over x minus 2. Now before you get to going too far ahead on number 5, there's something that's a little different about that one. So are there any questions so far? Okay. Number 5, the one thing that will cause you to mess up, the only tricky part of this, is you need to make sure that you have all terms, 1 that are in order and 2 that you're not missing anything. Notice on number 5, I'm actually missing an x squared. So I went from x cubed down to x. If you are missing one of those terms, you have to put a 0 in its place. So when we do our setup, what goes in the box? And then across the top, I'm going to have 1, 0. Because I have 0x squared. -17, 32. So you bring down your first number. And then you multiply. What do I get when I multiply? And then I add to get -5. And then I multiply to get 25. Add. I get what? 8. Multiply. Negative 40. Add. Negative 8. Good. So this is my remainder. This would be my constant, my plain number. This would get an x and an x squared. So my answer is x squared minus 5x plus 8 minus 8 over x plus 5. I want you to try number 6. So you should have put an 8 in the box, and then 8, negative 64, 0, 3, negative 28. So bring down the 8, multiply, add, multiply, add, multiply, add, multiply, add. So you should have had 2 zeros in your answer. When this is the case, we're still going to label remainder, number. This next one will be my x, x squared, x cubed. We still label the same way, but when you write out your answer, you don't need to put the zeros. So my answer is 8x cubed plus 3 minus 4 over x minus 8. Any questions?